Hello, good evening everyone. Today we are going to switch from continuous function to discontinuous functions, how to do Laplace transform for discontinuous functions. There is many application for discontinuous functions in engineering. For this reason we are switching from continuous to discontinuous. Let me start by the first function, which is a Heaviside function. Side function, and in the book this function is called unit one side function. Unit one side function. Let me just show you what kind of function is this Heaviside function. Here is the function. It is called U. U for unit. It is coming from the word unit. So U of t equal to 1 when t is greater than 0, and 0 when t is less than 0. So U is coming from the word unit. Yeah. Now let me just show you the graph for this function, just to tell you what kind of function is this. So we have here the t, and here is u of t, right? U of t. Now when you graph this, then it is here 0, and here it is discontinuous at t equals 0, and here is the 1. So we have such function. So here is 1 unit. Yeah. So this is u of t. Yeah. Now let me just adjust or do shifting. So we may do some shifting for this function, and we get a shifted function or a transited function. So let me do shifting, some shifting. With shifting for u, you will have something like u of t minus a, right? This thing is 1 when t is greater than a, and 0 when t less than a. So what is the difference between this this and the Heaviside function? It is the following. So let me show you. So this is the new one. It is at t equal a, so this is t, this is the a, and here it is 1, yeah, 1 unit. So this is u of t minus a, yeah, and here it is 0. So 0 when t less than a, and 1, it is 1 unit when t is bigger than a. So this function has a jump discontinuity. So it has a jump discontinuity. For removable discontinuity, we don't have any problem in integration, but for jump discontinuity, we have a big problem where you need to cut the integral at a or at 0, and make the integral from a up to infinity, and another part from 0 to a. Now let me go with another function. So I'm giving some examples of discontinuous functions that we will deal with them. We will do the Laplace transform for them. So first I'm just defining some discontinuous functions, and then I will do the Laplace transform for each of them. So here is a new function, which is this function. Let me just show you. It is called pi, and here we have a and b. Yeah, this function is 0 when t less than a, and it is 1 when t between a and b. Yeah, this is a. And we have 0 when t bigger than b. Now if you go and calculate this one, just to let you know, this thing is just ut minus a, and minus u of t minus b. What kind of function is this? Let me show you the graph for this function. It says I have a value, or the function have a value. The function has a value, sorry, the function has a value from a to b here. It has the value 1, yeah? And here, when t less than a here, the value is 0. So 0 here, 0 there, and here it is 1 unit. So this is pi of a comma b of t, of course of t, right? This is called window type function. So it is called rectangular window function. So this is called a rectangular window function. So it looks like a window. So if you look here, so you look here, it looks like a window. Now, why the function is just a Heaviside with a transition t minus a and minus a Heaviside function with a transition b. Now, just if you look here, what is that thing? If you graph this one, then here is a, right? And here, say you have 1, and here you have 0, right? So here you have 1 up to here, right? And you have 0 here, right? Do the other one here on another line. If you do the second one here, yeah, here is a, here is b, yeah, here is b, and it is here it is 1 unit, and here it is 0 units. So when I plot this thing, this is 1. When I plot that one, it is also 1 here and 0 otherwise, yeah? Now when you subtract them, it's clear when you subtract 1, so when you subtract, so what you're gonna have here, and draw them, so 1 minus 1, when you are bigger than b, 1 minus 1, then you get 0. So here it is kind of 1 minus 1, right? And when you are here, then it is 0 minus 0, right? And when you have here, you are 1 minus 0, yeah? So 1 minus 0, 0 minus 0, and 1 minus 1. So here 1 minus 1, 1 again, 1 minus 0, and 0 minus 0. For this reason, we look at this as a transition for the Heaviside with A units and a transition for the Heaviside with B units. Now let me just also show you if you multiply a normal function, so if you multiply a normal function, so multiplying any function, any f of t with Heaviside, function. Heaviside, we call it Heaviside because one side is heavier than the other. So one side is 1, the other side is 0, so one side is heavier than the other. Now, let me just say I have a function called f of t, right? So here is a function called f of t. This is t, and now I'm drawing f of t, yeah? Y equal f of t, yeah? And now, I need to multiply this. What about if I do something like f of t times, say I'm gonna go with u of t minus a, yeah? So what's gonna happen to the graph? I'm gonna show you. So when you go with this thing is 0, so here is the a, right? Here is the a. So when you are less than a, then you are multiplying with 0, right? So this is kind of, you multiply with 0 and 1. But here when t is bigger than a, and here when t is less than a, sorry, the other way around, t bigger than a, and this is t less than a, right? So when t less than a, you multiply with 0, then you get that thing, right? You get 0. And so it is kind of, you take that part here up to here and you get that part. It is the only that part. This becomes 0 and you're going to have only that part of the function, right? But here you're going to have a discontinuous point. So this is f of t, right? So f of t is just this part, so this part of the function, because this part you multiply it with 1, but that part you multiply it with 0. Then you end up with that part of the function. So the function was like this, and then you kill that part and you keep that part. Note that also any function with jump discontinuity can be written using the Heaviside. So I can go, for example, with a function like this. If you have f of t, for example, which looks like this, 1, and when t is bigger than 2, and you have 2 when t is between 2 and 3, yeah, and you have here t squared when t bigger than 3. Now this thing, if you want to write it using the Heaviside function, I can look at that function to be defined only between, so let me just show you what is going on. So here is the 2, here is the 3, right? So when you graph this function, you get 1 unit here, yeah? And here you get 2 units here, yeah? 2 units here. And then later you have t squared, I don't know, t squared, maybe, I don't know, maybe like this, yeah? Maybe like this, yeah? Yeah? Sorry, up to here. Yeah? Now, when you do this, this will be like you are taking the number 1 in between 0 and 2. This means that you need just the number 1 between 0 and 2, right? So I'm using the pi function, which is the window, the rectangular window function, which means that I have 1 between 0 and 2. And now this is plus, I need 2 with the window 2, 3. And I have the third one. The third one is not a window, so it is a Heaviside function. So I need 1 when t is bigger than 3. For this reason, I have 3 times the Heaviside function, which is u of t minus 3. Yeah. So imagine that this one is 1 unit when t is bigger than 3. So for this one, you need that in that window. You need 1 in that window. You need 2. And for one side, it is not a window, it is one side bigger than 3, you need 3. You need t squared, sorry. You need t squared here. So I'm taking these numbers just so that you can follow me. That 1 is going here, right? And that 2 is going there, yeah? And that t squared is going there, yeah? And this one you need it inside the whole, inside the window 0, 2. That one you need it inside the window 2, 3. And that one you need it to, I can say, from 3 up to infinity. This is just to show you that any jump discontinuous function can be written using the Heaviside function, or the Heaviside function and the rectangular window function. So for any jump discontinuous function, you can use the Heaviside function to rewrite the function. For this reason, all the Laplace transform will focus on the Heaviside function. So we will do the Laplace transform for the Heaviside function, and we will not go for any jump discontinuous function, because any jump discontinuous function can be written using the Heaviside function. Now let me go now and write 3 rules now the rules are for the Laplace transform. So here rules. I will list the rules, then I show you the proof. The first one is, what is the Laplace transform of the Heaviside function? And what is the Laplace transform for the Heaviside function with a transition or with a shifting? So what about u of t minus a? And what is the Laplace transform of something like this? F of t minus a times the Heaviside function with the same transition, yeah? And what is the Laplace transform of g of t times the Heaviside function with a transition, u of t minus a, yeah? Let me start with the first one. So what is that function, just to give you an idea? So this function is, I'm writing here, I will write the rule now, but let me just show you one thing. This u of t is just t, 1 when t is bigger than 0, and 0 when t is less than 0, right? Now if you go with the Laplace transformation for u of t, it will be the integral from 0 up to infinity, and then here e minus st, I'm using the definition for Laplace transform, times u of t and dt, right? Now let me go and see what is u of t when t is bigger than 0. So here, look here, so you have t is bigger than 0, so here in that integral t is bigger than 0. When t bigger than 0, then u of t is 1. Then you're going to have e minus st times 1 dt, right? From 0 up to infinity. Then you will discover that you are doing the Laplace transform of the number 1. So the Laplace transform of the number 1 from the table, the first line, it says it is 1 over s. So the answer for the first one, the Laplace transform of the Heaviside function is 1 over s. Now what is the Laplace transform of the shifted Heaviside function? Now let me show you what is the answer for this, and I will prove it for you. It is minus s times a here with a minus sign, so e power minus as times 1 over s, so times 1 over s. How we got that thing, I will show you. It is very easy, applying the definition of Laplace transform here. So here is, if you go by definition, so how did you get this thing? It is the integral from 0 up to infinity, right? And whenever you do a Laplace transform for anything here, if you remember, we were putting this red, I remember it was red here, yeah? So you take that thing here, ut minus a, right? You multiply this thing with e minus st, and then you integrate from 0 to infinity. Now for this thing, I can do some substitution for this. So this thing is the Laplace transform. So I'm trying to do the Laplace transform of ut minus a, right? Now with some change of variables, so let's say I'm doing v sub, yeah? V sub with v equal t minus a, right? And now just because I'm changing variables here, so if t is 0, and if t is going to infinity, so let's say it is going to infinity, and here is v. If okay, that's fine. Okay, now when okay, so when t is 0, you get minus a, right? And when t is infinity, then you get this is infinity. Then what you're gonna get for that integral? So for that integral, you get the integral from minus a, yeah, from minus a up to infinity, yeah, and then here e minus s times here you're gonna have now from this thing I can have t equal to v plus a, yeah, and then I have v plus a here, right, and then I have u of v, and then also I can get dt equal dv, right, then I'm gonna have dv here, right. Now let's take that part outside, then I'm gonna have e minus s v, and then minus sa, and then I have the integral from minus a up to infinity, yeah, and then here u of v, and then dv, yeah. Let me go. So you have now your function u of v. You have an interval from minus a, right, up to say infinity, right. So now here we have the 0, right. Here the function is 0, right, and the function here is 1. For this reason, this integral will be two integrals, so I can rewrite that integral using, so I can write this integral using two integrals, one from minus a up to 0, and I have e minus v times s minus sv, right, and then I like to write this as two exponentials, and the second one is minus sa, right, and u v dv, but u here is 0, and the second integral here equal, so the second integral will be the integral from 0 up to infinity, right, and then I'm gonna have minus sv e minus sa. I need to take this out of the integral. I will take it here out of the integral. I will get minus sa, right, and then here we're gonna have u of v, but u of v in that side is 1. When v is greater than 0, you're gonna have 1, right, and then dv, yeah. Now all what we got here from that integral, so we got this thing, yeah. This is the end of the integral. So when you need the Laplace transform, so the Laplace transform of u t minus a, then you get that thing. This thing is just e minus sa, and this thing is just you know, v is a dummy variable here, right? Does not matter whether you call it v or you call it t. For this reason, this thing will be the Laplace transform of the number 1, right? And this means minus sa times, what is the Laplace transform of 1? It is 1 over s. 1 over s, yeah? So I ended up with that rule. So we have, this is the first rule that we did. This is the second rule that we have. If you shift the Heaviside function or the one-side function, then it is like when you do the Laplace transform, it is like 1 over s times e power minus a times number of units shifted times s. Let me write the third rule now. All the rules are done in a similar way. So here is the next one. The next one, the rule says this thing will be just e minus as like before, and then you do f of s. In other words, e minus as times the Laplace transform of small f of t, yeah? So when you have the same shift here, so they are matching, right? So we have matching, which means same shifting, same a, yeah? If you have the same a, same shifting with the same shifting in the function f and the Heaviside function, then this thing, the Laplace transform of the product, is like doing the Laplace transform for f of t without any shifting, and then multiplied with e power s times minus the number of shifted units. So this thing, so let me keep this. I'm gonna just go down a little bit here and write the last one. The last rule here, rule number 1, rule number 2, and rule number 3 here, right? Here, rule number 4, it says if you have g of t, no shifting for this function, I just change the name because this one with a shifting, this one with no shifting, or a shifting different from the Heaviside function. What should I do in this case? It says you still because you have a Heaviside, then you need to multiply with that exponential. So when you have a Heaviside, you multiply by that exponential. So I still multiply with that exponential, and then here you need to multiply with the Laplace transform. First you shift g with a units, yeah? Shift g with a units, then take the Laplace transform. So first step, shift g plus a units, yeah? And then step 2, take the Laplace transform. Laplace transform of shifted g. You need to be careful of this because here you do first shifting, then the Laplace transform. When we do the Laplace inverse, then first you do the shifting, then you do the Laplace transform. Yeah. So if we are doing the inverse Laplace transform, then first you do the Laplace inverse, then you do the shifting. It's the other way around. So when you do just as a remark here, let me write it, remark. When you do Laplace inverse, then these 1 and 2 become 2 and 1, yeah? 2 and 1. I will come to this later. So you do them in the inverse. It is like the socks and shoes rule, which says first you wear the socks and then you wear the shoes, but when you take them off, then first you take off the shoes, then you take off your socks. Okay, what is next? Next, we're gonna start solving some questions. So solving questions from the textbook, from your textbook. So first, we're gonna start with question number 1, page 412. Question number 1, page 412. It says, sketch the graph of the function and determine the Laplace transform. Sketch the graph of the function and then find its Laplace transform. Let me give you the first function. It says this function is t minus 1 squared times the Heaviside function shifted 1 unit. So t minus 1. This is your f of t. Yeah? It is not your f of t, but I'm gonna just imagine that this thing is just a product of two functions. Yeah? Because I'm gonna consider this to be f of t. Yeah? Now let me go with a solution. So what is the graph for this function? First, I will graph this function, which is, this function is t minus 1 squared. You know, if you want to graph t squared, so this is t squared, right? So this is y equal t squared. Yeah? But if you want to graph t minus 1 squared, so you're going to have here, this is 1 unit here, and this is t, right? This is t, and this is the function, I don't know, maybe f of t, right? Yeah? Now this is the function which is t minus 1 squared, right? This is t squared. Now if you want to multiply with the Heaviside function, this Heaviside function, just this guy here, just the rule, it says this thing is just equal to 1 when t is bigger than 1 and 0 when t less than 1. Now when you are here, okay, when you are bigger than 1, then you multiply this with 1, right? So you multiply this with 1, so times 1, then this is not changing except here. So this side is multiplied by 1. When you multiply by 1, then you keep the rule for the function. Except here at 1, then at 1 it is undefined because you multiply with a function which is undefined, or it is discontinuous at 1. Now when you are here, then you multiply with 0, right? So you multiply with 0 here. So in this case, I take this side off, and then I'm multiplying with a Heaviside function. So this is ut minus 1. So what did I do? Just I killed the part of the function which is less than 1. Now, how to find the Laplace transform for this function? So let me compare with the rules. Comparing with the rules, now how to find the Laplace transform? Look at t minus 1, right? Squared multiplied by ut minus 1, and compare it, because you have here a matching minus 1, then I will compare this with f of t minus a, right? Times u of t minus a. Now if you compare with this, it is clear that your a will be, now comparing here, a is 1, yeah? And if you compare f with that thing, so f of t minus a, f of t, now I know what is a, right? F of t minus 1. It will be t minus 1 squared, right? Then f of t, if you just consider this as v, yeah? If you consider this v and this v, right? Then f of v is just v squared, yeah? So what did I do here? I just consider t minus 1 to be v. So f of v is v squared, and f of t, if you like, is just t squared, right? So this is what we want. So we have a equal 1, and we have f of t equal t squared. Now we don't need the question anymore. Now let me show you now how to do the Laplace transform for this thing, which is t minus 1, and then u squared, u of t minus 1 squared. So I'm using here rule number 3. Rule number 3, it says when you, sorry, we don't have square here. When you multiply by a Heaviside function shifted by a units, then you multiply by e, here, let me write minus a s, yeah? And then here we have f big of s, right? Or if you like, this is e, we know what is a now, it is minus 1s, right? Now what is f big of s? It is the Laplace transform, this is the Laplace transform of t squared, yeah? So this is f small, and the Laplace transform of f small is f big. Now you need to go back to that table 7.1, and compare this with line number 2, line 2. So line 2, in that table, it will be e minus s, right? And this thing will be 2 factorial divided by s power n plus 1. It says here n plus 1. N plus 1 means 2 plus 1, right? Now let's continue with this. It is kind of, you get 2, so e minus s, and here you get 2 factorial is 2 over s cubed. So we are done. So this is what you're gonna get. Next. So let me go with question number 3. In question number 3, he is changing the function now, same page, question number 3, and I have now t times u t minus 1. Now this is the function. It is kind of a function f of t, I'm gonna go because I'm applying here rule number 4. Why I'm applying rule number 4? Rule number 4 says a function without any shifting, and here a function, a Heaviside function shifted by a units. Now this is kind of, I'm looking for g of t times u of t minus a, right? It is kind of, you have a function g of t, right? G of t is t, yeah, I'm comparing. So this guy is that guy, so this guy is that guy, and this guy here is that a, right? So, and I have a here equal 1 unit. Now, if you want a graph, for example, if you want the graph, then very easy. This is t. And now, let me graph first g of t. G of t is t, then this is the graph. So let me change the color. So you have the graph, which is this graph, right? G of t equal t, right? Now the Heaviside function says that, so what is the Heaviside? Heaviside function is 1 when t is bigger than 1, t bigger than 1, and 0, so a is 1, right? Here a, this is a, right? And this is just, it is because it is a unit function, so u unit 1, right? And then t less than 1, right? Now this thing means whenever you go to the number 1 here, then you need to kill the function which is less than 1. So anything less than 1 here, so here I make a circle, anything here should be killed, yeah? So this guy here is killed, yeah? Yeah? Killed because it is multiplied by 0, right? But that thing here stays, yeah? Now what I got here, this is what I got this thing, yeah? I got this thing, which is the, yeah? I got this, which is t times u of t minus 1, yeah? Then this is our function. Now what is the Laplace transform for this? I give you a rule for this. Let me show you how to do this. How to do this. The rule says the following, right? The rule says if you do the Laplace transform of g of t times u of t minus a, right? Then this thing is just always you multiply with e minus as, right? So whenever you have the Heaviside function shifted a units, then you multiply by the exponential in the s word or the s domain, yeah? And then here you do first, you shift g of t plus a, and then Laplace, right? Now then this thing, I know a, yeah? When we compared here, don't forget that your a is 1, and don't forget that g of t is just, so let me write them here, So we know now that our a is just 1, and our g of t is just t. Now it says, what should I do with g? First shift g, then you get g of t plus 1, yeah? G of t plus 1, right? Equal to t plus 1, right? So you replace t with t plus 1, then replace t with t plus 1. Okay, now let's go and apply this. Then the Laplace transform of t times u of t minus 1 will be just e minus a s minus as, so minus 1 times s, and then the Laplace transform of gt plus 1 of t plus 1, right? But I know that the Laplace transform is linear, right? So e minus s, and this will be the Laplace transform of t plus the Laplace transform of 1, and don't forget to multiply all that with e minus s. So you get e minus s, and this thing, again, I'm applying here rule line number 2, line 2, and for the second one is line 1 here, line 1, yeah? Now from line 1, this is 1 over s, and from line 2, you get just here n is 1, right? So here we have 1, so n is 1, right? So you get n factorial, so you get 1 factorial over s power n plus 1, then 1 plus 1, right? Now you can simplify this, and you have now the Laplace transform of that function, which is t multiplied by the Heaviside function shifted 1 unit. Next. Now let's go with something doing the Laplace inverse. The Laplace inverse. Let me write the rule here just to tell you what is going on. So when you have something like, what is the Laplace inverse of something like e minus a times s times f big of s, yeah? This thing will be the following, will be u of t minus a, u of t minus a times this thing, which is f of t minus a. Yeah, let me tell you the story. When you see, if you see this thing, e minus as, then when you go with the Laplace inverse, if you see this, then you go right away to Heaviside function. Yeah, then you need, if you multiply, so if you multiply with e minus as, then you need to multiply here. So okay, so I may write it in a different way. So here we have S domain, yeah, and we have T domain, right? Yeah, let's go like this. Now if you here multiplying with e minus as, if you go with Laplace inverse, then you need here to multiply with ut minus a. Yeah, then you multiply with ut minus a. Now if you have here f big of s, right? How about, what about fs times e minus as? Now for fs, to go to f of t, first you go to f of t, then shift at a units, which means you're gonna have f of t minus a. Good? Yeah? If you have this thing, then this thing gonna give you the Heaviside function, shifted a units. And what about that function? Then first you do the Laplace inverse, and then you shift. Let me give you an example on this. I'm solving, for example, question number 11 in the textbook. Question number 11, determine the inverse Laplace transform of the given function. Determine, question 11, determine the Laplace inverse of the given function. So here is the function. It says you have e minus 2s, I think, over s plus 1. Yeah? Okay, now solution. Now solution. So I'm not rewriting this again, so we need the Laplace inverse of this thing. As I told you before, when you see e power number times s with a minus sign, then this thing means you need to get a Heaviside, shifted Heaviside, shifted Heaviside. Yeah? So this thing will be u of t minus a, right? But if you like, what is a? A is this thing without the minus sign, so this is the a. A is 2. Then here you take that 2, you take that a, and you put 2 here, right? Now the next thing is to go and do, you need here f times f of t minus 2 also, right? Same shift, t minus a. So you have t minus 2, t minus 2. Now the only problem is, what is f of t first? So step one, find f of t. F of t is, let me just tell you the story. If you have this thing is e minus 2s over s plus 1 should equal to f big of s times e minus 2s, yeah? Now, it's clear that your f big of s is just 1 over s plus 1, yeah? Now, if you need f small of t, it will be the Laplace inverse of that thing, Laplace inverse of 1 over s plus 1, yeah? But if you go to the table now, go to the table here, go to the second column in the table, and go to row number 3. So row number 3, line 3, line 3. Be careful, because here in my table here, I'm just switching the place of line number 2 and line number 3 in the book, right? So here, using line number 3, it's clear that your a here will be, this is just to tell you, 1 over s plus 1 should be the same as 1 over s minus a. Then your a should be minus 1, right? Your a is minus 1 now, right? So in this case, if you go backward, you're supposed to get e at, yeah? And your a here is minus 1, then you get e minus t. What is that thing? That thing is your f of t, right? Now this f of t should be shifted 2 units. So you need to shift this 2 units. Now let me change the color and tell you from this here, if you like to go with f of t minus 2, yeah, it will be replace t with t minus 2, then e minus, instead of t you get t minus 2, yeah, t minus 2. And now take this thing and put it there, right? And then finally the final solution, I'm writing now the final solution. Here is the final solution for this. It will be just the Heaviside function shifted 2 units times exponential minus t minus 2. and we are done. So this is the Laplace inverse of that function. So changing the function from frequency domain to time domain, then because of that exponential you have the Heaviside function, and you have your function is shifted to units. Next. So let's go and solve another question, which is question number 15. Question number 15, more questions on the same, just to master this thing. It is S, you have SE minus 3S over S squared plus 4S plus 5, plus 4S plus 5. And he is asking what is the Laplace inverse for this thing, yeah? Now this is in the S domain, in the frequency domain, and you need the function in the time domain. Now you need the Laplace inverse of this thing. Let me compare this thing with E minus AS times F big of S, right? Now this thing, it is clear that your A now, comparing this with that thing, your A will be 3 units, yeah? Yeah? So I'm just comparing here exponential with exponential. So minus A is minus 3, then your A is 3. Next. So our next thing is, what is your F big of S? F big of S is just S over S squared plus 4S plus 5. Yeah? Now if you need F small of t now for this thing, then it is so you look at the second column in that table. Do we have that thing which says you have an S squared and another S here? Never having in the denominator any 2 S's in the denominator. For this reason, you go and think with partial fraction. You know that the degree of degree here is 1, and the degree here is 2. Degree is 2. And now for this one you need, because you have degree 2, then you think of completing the square. So before doing anything, I will complete the square here, S over S squared plus 4S, and here is the 5, right? And now here I'm adding and subtracting, so I'm adding 4 and subtracting 4. So if you go with minus P over 2A, and P over 2A plus minus, yeah? And squared, then you will get here plus minus, what is B? 4 over 2 times 1. Then you get 2 squared plus minus 2 squared. So plus minus 2 squared, then you get 4. So I'm adding and subtracting 4, and we have that 5, right? Now let me just erase this thing and show you what's going to happen here, because we did completing the square before. So I will not focus a lot on this thing. So we're going to have S over S plus 2 squared. And then these things together are making 1 unit, right? Plus 1. And I like to have that one as 1 squared, yeah? I can look at that one as 1 squared, right? Yeah? So I'm looking at this as 1 squared. Now going back, I have one S in the denominator. Looking here, yeah, all of them having one S in the denominator. But if you compare with something like shifted S and squared and a number squared, then you're going to have 2 of them here and here, line 7 and 8. So you go with line 7 and 8. If you go with line 7 and 8, you're going to have sine and cosine. But because you have an S here, then you need to go not with line 7, you go with the line 8, which has the cosine, because you have an S there. Now, the only problem is S should come here with that S should come here with the same number here. So if you have a 1 squared here, then you're going to have a 1 here, right? But because you don't have that 1, then you add and subtract that 1, and adding and subtracting, changing nothing on your function f. Now let me continue here. So I'm going to cut this into two parts. I will consider this as s minus 1 over s plus, let me just here, sorry, I don't need 1 here, I need 2, right? I need that 2, right? I need plus 2. So sorry, here I need plus 2, yeah, plus 2, and I need here minus 2, right? Because I need the shift, which is a, s minus a, s minus a. So I don't need plus p, I need s minus a and s minus a, right? So I need s plus 2, and here s plus 2, right? And then squared, and then here we have 1 squared. And the other one, I like to cut it into a second part here, just to show you. So I'm taking two parts. This is the first part, right? And the second part is here, that minus 2 is going with the denominator. And finally, I got two parts for fs. This is fs. I'm just trying to make it nice, so I'm gonna write it minus 2 over, and here the second part is s plus 2 squared, and then plus 1 squared, yeah? Now I need now to go with f small of t, right? F small of t. Now what is f small of t, yeah? F small of t is the Laplace inverse of the first one, s plus 2 over s plus 2 squared, yeah, and then plus 1 squared, yeah, and then here, because Laplace inverse, let me just erase that part. Now Laplace inverse is also linear, then, and I also like to take the 2 out of that Laplace inverse. So I have the following, and here minus 2, this is the minus 2 here, and then Laplace inverse of that thing, which is 1 over s plus 2 squared, and then plus 1 squared. Now I'm going to go back and change my mind, and I say this compared with line 7, but this one is compared with line 8, right? Line 8. So this is compared with sine, and this compared with cosine, because the cosine has an s in the top, and here it has a number which is 1 and 1, right? 1 and 1. Now if you compare here and you look at a will be minus 2, and b here is 1. Same a and b, a here is minus 2, and b here is 1, okay? Now finally, what I got here, so I got the following. So I got that this thing is just s plus 2 squared, s plus 2 over s plus 2 squared, and then plus 1 squared, right? And then the other one here, minus 2, yeah, minus 2, and here I'm getting 1 over s plus 2 squared plus 1 squared, yeah, 1 squared. Now if you want f small of t, for the first one you're going to have exponential at, but we know that a is minus 2t, and then we have here cosine bt, b is 1, so you're going to have 1t, right? So here is b and here is a. And then the other one is minus 2, I took the minus 2 outside, and then times, I'm writing here, I'm going to have e minus 2t, and then sine 1t, right? Now, but when we have something like this, a function like this, then you need, when you go back, you need here shifting for f of t. Now shifting. Now you need f of t. Now what is the shifting here? The shifting is 3. So f of t minus a, or f of t minus 3, it means that you go for every t here and you replace it with minus 3. So every t is replaced by, so here it is equal to e minus 2, and here t minus 3, right? And then cosine t minus 3, and then minus 2, e minus 2, t minus 3, right? And then sine of t minus 3. Yeah? Now going back, so what is the Laplace inverse of this thing? If you want the Laplace inverse now, so the Laplace inverse finally, let me just, maybe we want now to rewrite everything. Laplace inverse of s minus 3s over s squared plus 4s plus 5. It says this thing will be u of t minus a, good? And then here f of t minus a. Yeah, and we know from here, we know from the beginning that your a is just your a here. A is 3. Then you have u of t minus 3, and you need f of t minus 3, and we already got f of t minus 3. Then you need just to take that function here. I will not write this again, and put it here. Yeah. So you go and put that function, and the sign between them is multiplication. Now why we are doing this? Why we need to know the Laplace transform for discontinuous functions? Why? So why Laplace and Laplace inverse for discontinuous? Actually, it is Laplace for discontinuous, but Laplace inverse is included in the same subject. Now, I'm giving you a question here. Most of the applications they have functions with jump discontinuity. For this reason, you may see a differential equation with a jump discontinuous function. It says solve the initial value problem. Here is question number 21. Question number 21 will answer this thing. Why we are studying this? It says solve the initial value problem. What is that initial value problem? It is y double prime plus y equal to u of t minus 3, u of t minus 3 half. And then the other one is y of 0 is 0, y of 0 is 0, and y prime of 0 is 1. Yeah? So here is a very special function here, a Heaviside function shifted 3 units. Yeah, this is a jump discontinuous function. It is a discontinuous function with jump discontinuity. Now, how we solve this? We know how to solve this. Yeah, there is a steps to solve this thing, to solve this equation solution. So first step, you take the Laplace transform for the whole equation. This is something that we studied before, Laplace transform of that equation, which is y double prime plus y equal to u of t minus 3, right? This is the first step. Now, the Laplace transform is a linear function. Then you have Laplace transform of y double prime plus Laplace transform of y equal Laplace transform of the shifted Heaviside. Yeah? Now this one has a rule. So the Laplace transform for the second derivative is the last line, line number 10. It says it is s squared, yeah, y big of s minus s y of 0, yeah, y small of 0, and then here minus y prime at 0, right? All that thing here, all that thing is just this thing, right? And then the Laplace transform of y, I'm writing this now here, so this thing is y big of s, yeah, this thing. And then the other side of the equation, now we learned about the Laplace transform of this thing. It says this is e minus as, but a here, a, so you know you have u of t minus a, right? Then your a is just 3. And here you're supposed to have e minus as, right? But I know my a, it is 3, then I put here 3, right? Yeah? And then multiplied by 1 over s. Yeah? Remember that this thing is like that, like the Heaviside multiplied by the function 1. And when you have a Heaviside, you have that thing. And when you have the number 1, then you have 1 over s. Now let me go with this thing and just I go to initial conditions. So the next step is to take the initial conditions and put them here in the new equation, right? Now what I'm gonna get now, I get s squared y big of s, right? Minus this times 0, you get 0. And this thing is minus 1 plus y of s equal to e minus 3s divided by s, yeah? This is the equation. And if you just collect the similar terms, then you have s squared plus 1 times y big of s, and then here plus 1 equal to e minus 3s and over s, yeah? The next step is subtract 1 from both sides, yeah? And then I'm going to show you what we have now. We don't need this. Then we have the following. We have s squared plus 1 times y big of s equal e minus 3s, yeah, over s, and then plus 1. We said minus 1. Good, minus 1. Yeah? Is it minus or plus? I think it is minus 1. Minus 1. So minus 1, then you add 1, and then you have plus 1. Yeah? Now divide by s squared plus 1, then the next step is to divide. Dividing by s squared plus 1. Then what you're going to have, you are solving for y big of s, right? Then here you have e minus 3s over s, and you're dividing also by s squared plus 1. And also you need to divide the 1 by s squared plus 1 plus 1 over s squared plus 1. Yeah? So everything is divided by s squared plus 1. So we are almost there, almost there. Let me just show you what is going on here. Now it says you already found the Laplace transform for your solution, but you are looking for y of t, y small of t. So this is your solution, but in the frequency domain. You need your solution in the time domain. Then this thing is the Laplace inverse of that thing. So you need to do the Laplace inverse of this thing, which is e minus 3s over s times s squared plus 1, yeah? And here the Laplace inverse is linear, so I do the Laplace inverse of the first and the Laplace inverse of the second. Yeah? For this one, it is right away. You go and compare this one. You need s squared in the denominator and a number squared. So let me write here. So we have a number 1, and if you like it is squared, and you have a number 1 here. So it is kind, you have b equal 1, right? B equal 1. Now you are comparing with sine, yeah, comparing with line 4. So this one with line 4, so sine. So this thing will be sine bt. So I'm gonna write here, this thing is just sine bt here. So you have 1t, right? Now plus, now this thing is tough a little bit because it says the following. When you have this thing, then know your a, right? You know your a. Then when you have this thing, then you have the Heaviside function, heavy side shifted a units. Yeah, but I know that my a is 3, then I'm gonna have u of t minus 3, right? Times, now here you need f of t, but t is shifted the same number of units, minus 3, yeah? So the first step is find, so we need first to find first, so first find f of t. So what is your function f big of s? Take that away, then you have f big of s. Now I know f big of s, just hide the exponential here, then this is 1 over s squared plus 1, right? But this function, if you compare it with the second column here, none of them looks like this one, right? For this reason, because this is of degree 3, this is of degree 0, then you need to go with partial fraction decomposition. Then I need to go with a over s plus, and this thing is ps plus c divided by s squared plus 1, right? Okay, now I need to find a and b. Now what is a and b? Now if you make a common denominator, you will discover that you have s times s squared plus 1, right, equal to a times s squared plus 1, and then plus s times, if you like, ps plus c times s over s times s squared plus 1. What did I do here? If you like, I multiplied everything with s and s squared plus 1. Yeah, then I got this. Yeah, now if you like, you have here, sorry, so I don't need this. If I multiplied, if I consider multiplying, then I have just the numerator, right? Now this thing means 1 equal that thing. Now I need, just because I don't have enough roots here so that I can find a and b, I will just multiply this out. I will get a plus b s squared. So I'm gonna have a plus b s squared. Yeah, I'm just collecting that, so I'm just multiplying this out, right? And multiplying this out here, and then collecting similar terms. Then I'm gonna have also here plus cs plus a, right? Now it's clear, constant equal constants, then a, this thing should equal a is 1. Now c, we don't have anything here, the coefficient, if you want to look at this thing, then you have here 0s plus 0s squared, right? Then also you're gonna have c should be 0, and 0 equal a plus b also equal 0, right? Now if a is 1, then b should be minus 1, right? Then I got b, I got c, I got a here. Then I'm almost done here, almost done. What I got now for f big of s is a nice function now. F big of s was not nice, it was 1 over s times s squared plus 1. It was not nice because it is not in the second column. Now, is it nice after that? It is now a over s, then I'm going to have 1 over s, and then here, let's see here, b equal minus 1. Then here plus cs 0, ps plus c. So you're going to have minus 1 times s plus 0 over s squared plus 1. So a, b, and c. Yeah? Now f, can I get f small? If you want f small of t, then this thing is the Laplace inverse of 1 over s, right? Plus Laplace inverse of that thing. Can I take the minus? Maybe I take the minus outside here, minus, and here I have s over s squared plus 1. Yeah? Now it's clear that this one is in the first row, then this thing is just the number 1. For this one, this is the first line in the table. Yeah? And this one is the fifth line in the table, which means you're going to compare with cosine, and here your b, if you like, your b is 1, right? And then you're going to have cosine bt, yeah? Then you're going to have 1t, right? Now if you go back to your solution, so here you have y of t, right? This is your y of t, right? Now let's go back to your y of t, right? This is y of t. Back to y of t, which is the solution for the differential equation. It is the Heaviside times the function shifted 3 units, which means every t in f of t should be replaced by t minus 3. So here is the Heaviside shifted 3 units. Here is the function f of t, this is 1, and this is cosine, and then you need to replace t with t minus 3, yeah? And you are done with f of t, and then finally you add sine of t, this part, which is that part here. And then here we are done. This is the solution for the initial value problem. So solution for the initial value problem. And we are done. Yeah? Okay, this is the end of lecture for today. I hope that you enjoyed the lecture, and thank you very much for listening, and see you next time.